Good morning, hello! How's everybody doing today? Happy Wednesday? Wait, no. Tuesday? What is today? Tell me, what is today? One of these things will tell me. Wednesday, oh, it is Wednesday. Happy Wednesday! Oh, time. I need to get, I bought a calendar. I haven't put it up on a wall yet to remind myself. And I know I have a calendar on my computer, but I would have to actually click on that or mouse over it to see. But it's feeling like a Wednesday kind of day if we can't remember what we're building or what day it is. Something like that. All right, so what are we working on today? Today... Where's my, there it is. I did a quick search for this earlier. We're planning on making the UFO in the Asteroids game. So I want to make something like this that's gonna fly around and shoot also bullets in the screen. So those bullets might take out the asteroids, and they might also take out the player too. So that'll be something interesting, is that we have to make sure that we can't get destroyed by our own bullets. Or maybe that'll be part of the game. Who knows? But anyways, that's what we're going to be doing here. And so looking at this, it looks like it's not like a true, at first I thought it was an oval, but the more I look at it, the more this feels like it's sharp lines. So if we draw this ourselves, this feels like basically we have a central line like this. Basically create something like this, and then create like that as our UFO. Is that correct? It really does feel like what it is. Which makes it interesting, because initially I thought maybe what they were doing was doing like a circle. Like another circle over. No, because that doesn't make any sense, yeah. I guess the circle would have to be like down to here. Then fill it in so you can't see it. I think I like this one a little bit more. So if we have the center right here, and like the center of the ship as far as we're concerned is right here, we can have a width and a height. And that will, yeah, that'll give us our lines. Okay. So let's go ahead and create a, so I guess we need to create the mesh for the UFO first. So let's do that. All right, what are we going to need? We're going to need a context. Besides that, I don't know if we need anything specifically. We might need like a size to be passed in. Yeah, we're probably going to want a size. Do I want the size to be like a tuple or something? I don't know. If I have just sort of like a basic size and make this kind of squarish, that might work. All right, so we want to actually build this thing. And how would it also be used? In our, I'm thinking that there's a random % chance either every level or just a random % chance that it appears. There can only be one at a time. And it would have to be a very low % chance. Because it would be running every 60 times per second. So every tick, every frame. That's what I'm thinking of. Words. I'm glad my tea is finished brewing so I can drink it now. Today's gonna be one of those type of days. All right. Ufo mesh. All right. So what do I want to do here? No, come back over here. There. There, that's what I want. A reference. So I'm thinking we can start, if we have like a 0 right here in the middle, we can have just a horizontal line to begin with, and then we can get this onto the screen at some point and then play around with it. So let's start with mesh equals oh, you need to be mutable too. And you're just a mesh builder too, as well. Well, it's all together, or do I want to do these all separately? Hey, you can't find it. Cool. Okay, so we're going to create a new mesh, and let's create a line. And so we have the size, so we know that's going to be like half the size. So dot line. Now I might eventually be able to do something like a polyline, where I go like starting from here, go all the way to the left, come down here, do this, do that, up here. Almost. That almost works. I could do polylines, and that would just give me all of the lines to draw. But they have to be connected, don't they? Or I can draw these as separate lines. I don't know if it matters that much. Okay, so points. Points is going to be a reference to a array of x and y. So if we have x be, let's start from like here to here. So that's going to be negative size divided by 2, with the y being 0. Oh, and you need to be 2 points. So that's like this. And then the other one is going to be size divided by 2, 0. Width, let's make you 2.0 so you're easy to see. And white. Wait a second. So in line, you take in points like that with a P, but you were expecting. Oh, yeah, you're incorrect here. Like that. Okay, that makes you happier. Then we build you, run the context. And then we return it, okay, the mesh. All right, so let's go ahead and create a UFO. We'll just throw this UFO in right at the beginning. So that could be in the main library. I could probably just do this here because it doesn't really matter. We're gonna remove this anyways. So create the UFO for testing. I mean, is that true? Or I guess I could create a system that's going to spawn the UFO. That might be better. So systems in main, we're going to do spawn UFO system. Oh, killed it. Okay, spawn UFO system. What are we going to need in? We're going to need the world. You're going to have immutable access to the world. And we're going to need context. Besides that, I don't know if we need anything. We're definitely going to return a result, but with nothing in it. All right, so good to go here. Let's, I guess to begin with, I don't want to create too many of these. I want to create one at a time. So if I'm going to spawn a single one, we're probably going to have a marker, and then we can do a search for that. Okay, so that means we have an entity type. And you're going to be a UFO. So we can query for any UFOs that exist right now. So that means we could probably have a function down here. So function does UFO exist? We're going to take in the world, which in this case can just be a reference to the world. And we're going to turn a result with a Boolean inside. All right, so let query equals query have a vector of just the markers, right? That's all we're going to care about right now. So names, of course, you don't know. Okay, so names marker to string, and that's all I care about. Okay, so we should have these. We can now loop through of all of our markers. So for marker and markers, let marker say data wrapper. And you're gonna hold a string inside. Okay, so let marker equals that, equals marker dot. We're gonna cast you. But can't do that without the cast components. I think it's in here, right? No, it's in world. Not the world methods, although we might need those too. Where? What is it? It's in the. Oh, BBECS components. That's what it is. So it's not world, it's components, cast components. That's what I want. Okay, so that makes you happy. Now we can get our marker out. Once we have the marker, it's a data wrapper string. We have to borrow it and then compare it. So if a dereferenced marker dot borrow, you're equal to entity types, of course. You're going to be the UFO to string. Okay, so if you're equal to that, then we found it, right? So that's going to be a return okay, true. We found it. Does UFO exist? Yes. However, if we reach the end here, we have not found it. So therefore, it's going to be return and okay, false. So we can do a guard clause here. If does UFO exist, then we're just going to do an early return like that. Pass in a reference to the world, and that should be happy there. Okay, so that gives us oh, and question mark you. All right, okay, so we can call if the UFO exists. Now, if the UFO does not exist, we move on to here. So then we're gonna create the mesh. So let UFO mesh is going to be equal to the create UFO mesh. We pass in the context, and let's just arbitrarily say that you're like 15.0. Okay, that gives us a mesh. So I should be able to do a world.insert, and if I remember correctly, we need what? In order to draw it out, we need a location, a rotation, and a mesh. Those are the only three things. I can create a location just sort of like randomly out here. So location, you're going to be a point new. Let's just say something like 50.0, 50.0. And we'll do rotation is equal to you can be 0.0. We don't care about that. All right, so world dot spawn entity with component. Okay, so let's start with the mesh. Okay, so mesh string, and our data is going to be the UFO mesh. Okay, then we're going to have, oh, let's not forget the marker to string, and you're going to be entity types UFO. Okay, then we have a location. Okay, so that's just gonna be our location. And then a rotation. All right, so that should spawn in a UFO, and it'll just sit there right now, won't do anything, but that should be fine. Let's go ahead and get this going. So we're gonna head back into main library, and we're gonna run this in update here. So spawn UFO system. We're gonna hand it a mutable reference to self.world. We're gonna hand it the context, unwrap you. There we go. So we should have a UFO just sitting in the world right at the beginning. And now, right now, it's just going to be our horizontal line. Oh, it is here, but 50-50 is not a good place. It's right behind score. I want to put you maybe like 500. That'll be a lot better. Here it is. There's our UFO. I feel like that's not going to be big enough for this. So first thing here, let's actually create a resource for this that we're going to insert in. So we already have, this is going to be names. We have to go back into names again, add this in here. We want like a UFO size. Okay, so our data, let's make this be something like 50 wide. Maybe not that. Maybe like 30 wide. Now we can grab this out. So inside of our not create UFO, or our spawn UFO system, we can have another function here. So function get UFO size, taking a world, which is just a reference to the world, return result with an F32 inside. So this is gonna be let size. Can't remember if I need to do that here. World get resource. Name your reference. Names, UFO size to string. Okay, and then we can borrow you here. That gives us a ref of the resource. Then we can cast it and return it. So we're going to return it okay. The dereferenced size.cast. Oh, right. Almost forgot. Have to that. Okay, so that should give us what we want. We can now get our UFO size up here. Okay, so now we have this UFO size. Instead of passing this in directly, we can now manipulate that later. So UFO size. If we run this again, that looks like it could be a good UFO. Now we need to build like little pieces of it on it. So I want like maybe like little lines coming down from there, and then that sort of like the horizontal line down below that too. But now that because we have that existing, we can just sort of like build this up and keep on opening up to look at it. All right, so that line. All right, so we need 2 lines here. So I do know that the Y is going to be, if I'm doing the line below, the Y is going to be half the size down below. So we're going to do size divided by 2. Okay, so that's going to be the Y. Now the X I want to be essentially starting again here with like our far left. But I then want to add some amount. Like I'm not sure exactly how much I want to add in. Like maybe a quarter, like maybe size times 0.25. And then this one is going to be yeah, I think that's how it works. We're gonna start there. Then here it's gonna be down. So we have like that starting position, and then I want for the, because if 0 is here, I want to just move over by a little bit. Actually, I wonder if I can get away with just negative size times 0.25, and then we can do size times 0.25. I wonder if that would make sense here. Expected 3 arguments. All right, what did you? Oh, right, because then we will have the width, 0 and color white. So if I do that, how do you look? Do I have that little line below? I do. Okay. Okay, this is starting to come together. let's see. I want to clean this up a little tiny bit. So like this stuff I think is fine, but like the width and the color, I think we need to keep going here. So width is going to be 2.0 and color is equal to white. And then here we'll just use width, color, width, color. That way I'm not having to like if I ever decide to change that, I only have to change that in one place. Okay, so let's say we do the top one now, which the top one's going to be exactly the same as this one here. Except instead of, well, the X is going to be the same, but for the Y, it's going to be a negative here. And besides that, everything is the same. Okay. I like where this is going. I kind of want it a little bit bigger. So UFO size, let's bring you to, let's try 50. Let's see what it looks like. I think that's going to be a lot easier to hit. Those small asteroids are already pretty hard, so I kind of like this a little bit more. Let's see now if we can get the lines connected along here. Now for this main one, I think a polyline might be best. So instead of just doing individual lines like this, I could probably do polylines and then do like the coming up, excuse me, going over, coming down, going over, reach the first and then back around. Or polygon will finish it if I start here. Start here. No matter what, I think just polyline will be right. Let's imagine if I do a polyline mode. I want a stroke. This is going to be our width. Points. So this can be just a reference to an array, and then there'll be an array of like arrays in here. So that will be what these are. And then we have our color. Okay, so let's say, I mean, if I start exactly in the center with like 0, 0. Let's say I start at 0, 0, 0, 0. And then we move over to the right-hand side. So that would be 0, 0 on the X. And then I want, oh wait, no, that wouldn't be 0, 0 on X. That would be size times 0.5, 0.0. Then I want to move up and to the left by like a quarter amount. So our size is going to be size times 0.25. And then we're going to have a negative size times 0.5. So that's the top right. Here, if we put this back, we can put a marker in where we are. So currently let's ignoring that for right now. this is where we are. So we've started here, moved over, came up. Now I want to do this line. Okay, so that's going to be negative size times 0.25. And then you are going to be the negative size times 0.5. Okay. And down to here. Starting at 0, 0 doesn't make any sense then, because I can't like actually come back around. I should really start here and then go up. So instead, let's not start there. We're going to start at 0 size. Okay, we're going to start right here. Yeah, that's where we go. Now, we're at, okay, 1, 2, 3. So down here on the left. So that's going to be negative size times 0.5 and 0, 0. And down here, we're going to be at negative size times 2.5, and we're also going to be at size times 0.5. Then we're going to be at size times 0.25, and we're going to be at size times 0.5. All right, so back up to here again, which is this first one. And then we're going to move all the way over to the left, which is going to be negative size times 0.5, 0, 0. So if we do that, I don't have any of these other lines here. We just have this polyline. And we build you and run you. What do you look like? I mean, that doesn't look too bad. Like, I think it's a good start here. I kind of like the idea of maybe moving down by 0.25 as well as opposed to 0.5. We can potentially make some of these variables here. So let's see what we can do here. We have quarter size. Maybe instead of like quarter size, because we want to like change it around. I don't want to like be too prescriptive of like the math. So like short line. So if I do something like short size is 0.25 like that. Now, every time where we have this like, so I like this for, we have let medium size equal to size 0.5. So you're going to be a medium, everywhere I have this size, you're going to be medium size, and everywhere here you're going to be the short size. And then what I want to do, okay, so everything else should be the same. Now this is going to be the horizontal wherever we have the 0, 0 for the Y. But where we don't have that, I want the medium size here. Here, let's do that. I want you to be a short size too. Let's see how this looks. Hey, look at that. I like that look a lot. You know, I wonder, can it even be bigger? What if I made it like 75? Yeah, okay. I think bigger is going to be better because it's going to be easier to sort of like actually see. Now I don't know if it's going to look good if I have like the little cap on top of it. I know that it exists in the original arcade. I kind of like this right now, but I want to try with a little cap just to sort of see what that ends up looking like. I can either do a separate polyline or like add into here, like after we go through some of this. Yeah, let's just do a separate polyline for the hat. I know it's not a hat. It's a it's like the bridge. Okay, so polyline. In here, we'll do another polyline. Okay, so for our strokes, we already have a short size in here, so I kind of want like maybe a tiny size. Now I have 0.25. Let's do like a 0.12.5. So like half of that even. I don't know if that's a good idea, but we're gonna find out. Okay, for the X, if I want like half of this distance now. So that was already was that a medium size? No, that's a medium size. That's a short size. So I want the tiny size on the Y. And we're doing a negative short size for the Y. Okay, so tiny size, short size. That's going to be like this point right here. Then we want to go up by probably another tiny size. So then we're going to stay with the X. So tiny size, and then we're going to do a negative short size minus a tiny size. Then we're going to move to the left. So then we're going to have just a negative tiny size. And then the same thing. So a negative short size minus tiny size. And then we're going to come back down again. So we're going to stay with a negative tiny size and just go with a negative short size. Okay, so if I do that, how do you look? I don't know. Maybe it's too tall. Let me try making tiny size like 0.9. That, what? Okay, 0.9 is way too big. Hold on. 0.09. That's what I was thinking. I mean, that could work. I want to relook at what the original looks like again. I mean, these are really, really small. This is super clear also. It's really crisp. I don't know if we really need that. Like the flying saucer is like very easy to sort of like see separately here. Let's try. I don't know. I can keep it like this and we can like turn the hat on or off or play around with it later. I can also have like a mini size. Size times 0.4, let's say. So if I did that, then we have like the right hand side could be tiny. So then I kind of want to go back to 0.125. So I want the X to be the tiny size and I want the Y to be U can be the mini size. So if I do that, it should be wider but less tall on top of it. Maybe a tiny bit taller. There you go. I think that looks a little bit better. Okay, so if we have this in the world now. If I want it to be flying around, we have to also give it an acceleration and a velocity. We can do that. So in here, let's give it an acceleration. So with component, names, acceleration, string, you're going to be a point new 0. Actually, I want to just do that here. So you're going to be acceleration, velocity, acceleration, names, velocity, string, and velocity. Okay, now if I were to give our acceleration, yeah, no, 0 there. Let's give you like 1. So you're gonna move down and to the right just a little tiny bit. We'll see how fast, like what the speed of that feels like. That actually feels pretty good for moving around. So when we have it updating its location, we could have it just sort of like hit the acceleration just a little tiny bit. Now when I hit this, yeah, I'm not like affecting that by accident. So like I'm not grabbing any acceleration I can find. And I can't hit it, that's fine. Like we're just gonna want to shoot at it. Okay, so if I want to have it move around sort of like in a random pattern, what do I want to do? I'm thinking we have a system for moving. So this will be move UFO system. Okay, so what are we gonna have? We're gonna have our world, which is a reference to a world. I don't think we need anything else. This is really just gonna be searching for the UFO and then moving it, then like adding an acceleration to it. So we'll start by returning okay here. First thing we need to get is we need to grab out the UFO. So we're gonna have a function get UFO, have the world, return a result. Inside of the result, we can have an option, and inside of the option, we're going to have, I guess, the index of like which one we're working with. So index is going to be a U-size. So get UFO index. That way, if it doesn't exist, we can return a none. And I think that's exactly what's going to happen. We're going to have a none gets returned if this doesn't exist. So we're going to say if that UFO index equal to well, does that make sense? Oh, I don't know. I don't know if it makes sense because I think we want to do is actually just do the query for it. So if we do like a let query world query vector have a marker. To string okay, so we have our markers here, and so we want to know which one we're getting. Now, we're also going to be getting not just the markers, but we need the accelerations too. And I think that's all I really care about here is just the accelerations. Now, get UFO index, we're going to take in not the world. We're going to take in these. We're going to take in the markers. So markers is going to be a reference to, so an array slice of a reference of component data. And then we're going to return the option size. So we're going to first start by for marker in markers. That gives us that. data wrapper of a string is equal to marker dot cast. Once we have that, we can borrow it and compare. So if dereferenced marker dot borrow, if you're equal to, okay, so now we need our entity types.
And I very much doubt, anyways, that any of the people that I listen to were the first ones to think of a particular regression.
That's going to be the UFO to string. Okay, so if you're equal to that, we want to return okay with a sum. Oh, index. Right, we need the index. Index and the marker, and markers dot iter dot enumerate. Okay, so we return that. Otherwise, we return an okay with a none inside. Let UFO index is equal to get UFO index, and we pass in those markers. Oh, and we also want to make sure that this is okay, let UFO index equals if let sum index equals u. If you exist, return the index out. Else, we're gonna just return early. Like that. That way we can continue on this horizontal line here, not like have to go in over and over again. Okay, so we've got the UFO index out now. So we know that the UFO exists in the world. And we know which acceleration it's gonna be. So now I could create like a random number. So let me create like a random acceleration. So random acceleration. It's going to be equal to a new point.
It's easy to churn out a lot of songs if you have a lot of different chord progressions in your mind and you know that, you know what, if I do this, I do this.
New. And then for each of these X and Y, we're going to do random, which should give us a number between like 0 and 1, I think. Oh, and you need to be like an F32, so it should be between, yeah, it might be between 0 and 1. I'm not sure. Random here. This is not going to be the full one I want. I want to just sort of like see if it's going to work here. That's going to give us a point, and then I want to say, okay, we want our acceleration. So acceleration, it's going to be a type data wrapper of a point. It's going to be equal to accelerations of UFO index. We have to cast you that. Then we're gonna have to borrow you mute. So that's and shadow you. Oh, I can just do the update here. So we can just do acceleration. So you have to be dereferenced dot borrow mute. And then we want to plus equals you to this acceleration, to the random acceleration. And that's kind of it. So if I do this, that should make it move if it exists, which it does exist at least in this iteration. Okay, so heading back to main library. So let's see, move UFO system. Pass it a reference to self.world. So if we run U, that's maybe a teeny, just a teeny, tiny too strong. That being said, it's working. Oh, we're giving it an initial velocity, aren't we? So in spawn UFO system, I want to have acceleration be 0 to begin with. And acceleration should reset every single. Okay, so that 1 is really strong. Now let's say, just to make sure that I've got this going right, using random there, I'm gonna do mute RNG. What? No. Rest analyzer. Why are you not doing it? Use rand. It's like, is it that? Oh, maybe. Go to RNG. So I get you, and then for each of you, I want to replace you with RNG.gen range. Cool, you don't know what you are. And I want negative 1.0 to 1.0. Oh, wait, that's not how it works anymore. I want you to be negative 1.0 to 1.0. Of course, you can't find it. Sure, just bring in the entire prelude. Why not? Okay, so now it can sort of fly around. All right, so I've got the movement system working properly. Now this is not the best movement because it's too random. It feels too fake. But we can use some noise. We can use some Perlin noise here. Creates. Is it just noise? I think it is. I think it's just noise. And then from here, I should be able to do Perlin noise. So just noise. Chantilly Cake, good morning. Purring or Perlin? It's Perlin. Named after the person who invented the idea of this type of random number. All right, so want our YAML file. YAML, wait. I go to TOML, not YAML. So we want noise. 0. Okay, then come back into move UFO. Richard, me, hello, good morning. So instead of this rand prelude now we're going to use noise. Actually, maybe you'll be able to figure this out now. Maybe, possibly. I think I want to have like ticks though, in order to like, okay, so we're gonna need the context. Of course, you're not helping me out. Use GZ, oh no, just context. All right, so if we get to this point, we're not going to use U anymore. Now we're going to create a new Perlin. So Perlin I actually probably want to pass in noise too. So our noise is going to be a new Perlin. Of course, you don't know what that is. Use noise Perlin. So then, given that, we can then do a noise. I think it's get. And then it's an array of like whatever like a negative or positive number is going to be. So if I do something like 0, 0, that's just never going to move forward. The way that Perlin noise works is it's on a like essentially imagine a graph of a random numbers, and I have to choose on the x-axis or y-axis where I want that. So it's a 2D number that I'm getting here. Although I might actually, I think I can go to like 4 or 5D. It's pretty crazy what this noise function allows me to do. So I want like the x and a y. To get that, I can do the same number across both, and it should be fine. So this is where I want to do something like let like the off x is equal to get the timer too. Timer ticks, pass into context. That will give me a U size here. And then I want to maybe, so it's gonna be, let's do this again, noise offset. This is gonna be like just a full number. So I want to multiply this by like 0.001. I want you to be a really tiny number. And then we're gonna have noise offset, and then for our Y, also going to be noise offset. And the way this works is it's going to give me a number between -1 and 1. You need the traits. Noise FN. So we need Perlin and noise FN. Oh, right. You need to be F64s. So then we convert you to as F32. So if I do that, timer ticks, you need to be an as an F64. So if I do a noise offset, now I could have a noise offset here also and like pass that in. That might be best for me to do, or to have like a struct that handles like the noise stuff. That might be good too. Let's try this to begin with. So heading back into the main library, let's actually store noise in here. So we're gonna do, oh, we have RNG in here too, nice. Rust seems complicated. Rust, I think like because I'm making a game and I'm also using a system called ECS, which is like a method of storing your data in like a various particular way. I think that may make it like feel a little bit more complicated. It can be simpler. It can definitely be simpler. All right, so we're gonna have noise, and you're gonna be a Perlin. There we go. You know what? Let's also pass in our offset. Let's just do this here. We can do a offsets. noise offsets. And then you're going to be a tuple of F64, F64. Now I don't need you in here, so we can just do you down. Okay, so noise, you're going to be a Perlin new. We're going to have a noise offsets. You're a tuple of, we're going to start you on 0.0 and 0.0. All right, so that makes you happy up there. So, okay, now if I'm going to be passing in noise and noise offsets on our move UFO system, instead of context, we can just pass in the noise and then the noise offset, which is a tuple of F64, F64. Then I don't need to get this entire offset here. We're going to grab you, so new noise number, and we're going to use our offsets of 0 here. Offsets of 1. Okay, so that should give us the proper point. Okay, so back to you in our update. All right, so you need the noise offsets and the noise. So we're gonna pass in, you need to be also, that's fine. Tuples copying that is probably fine. However, you need to be a reference. Okay, so we're gonna do self dot noise offsets and then a reference to self dot noise. And then at the very bottom here, we need to make sure we update this. So let's do a self dot noise offsets dot 0 plus equals to 0.01, something like that. Self dot noise offsets dot 1 equals to 0.01. So if I do that and we rerun you, our ship should now move smoothly, and it should still be random, but it should be in a very like a different type of random, which is really cool about like Perlin noise, like what that actually gives us. It is unfortunately only moving on the diagonals. So why is that? Thought that it was giving me a number between 0 and, well, okay, so we know it's giving a number between like -1 and 1. Oh, but it's the same number. I need a different number. Don't I? In our move UFO system, so our random acceleration, our X is exactly the same. So these nodes are exactly the same in X and Y. That's our problem. We need these to be very, very different. So let's say I just take these and I add like 10,000 to each of them. Then we should be different because it's gonna be very different on the graph of random numbers. Now it moves sort of randomly around. Now, I want you to be very much slower. So 0.0 isn't right. I need to scale you way down. So I can do that here. If we do like make you mutable, then I can do random acceleration dot multiply scalar. Let's scale you down by like a 0.5, like cut you in half. Error. Well, that's semicolon would be helpful. I probably want to clamp it too to make sure it doesn't do this and just move forever. So I want to be able to clamp it. I don't think that I have a clamp. If I have random, yeah, I don't have like a clamp. Now a clamp, what I mean in this case is, I want to be able to come into this point and set it to be like at maximum a certain number. So if we have a pub function clamp, mute self, and then we want like the maximum. So we can take in a max and a minimum. So a max is going to be an F32. A minimum is going to be F32. I'm not going to return anything. We could return an error. That might, well, I don't know. It depends upon how I want to handle this. If we're, okay, so if we're above the max, so if self.x, if you're less than min, then we want x to be equal to min. Else if self.x is greater than max, then self.x is equal to max. We want to do the exact same thing for our y's. Okay, so if self.y is less than y, min, oh, you need to be a self.y. Okay, so then we should be able to clamp you here. So oh, that's not going to be here though, is it? That needs to be not here. Our maximum, okay, so what is it? It's our, we have a system for move. So I think update movement. Yeah, okay, so here's where we're getting our acceleration, velocity, and location. So after we update our velocity, so we get our velocity here. Okay, so we update the velocity with the acceleration. I kind of want to clamp the velocity. So I want to say velocity dot clamp with our maximum of, I don't know what I want you to be. Let's just say like your 2.0 negative 2.0. I want you between those. Okay, there we go. Now, will you not be too fast? Now, does this mean I'm not fast enough? But yeah, this is my maximum speed now. It's... yeah. Kind of want to not do that to myself. So let's do like 5. Now we can move around at a decent speed like this. I can't get too insanely fast anymore. This feels like a, I mean, it feels like good movement to me, which means I can still die. All right. Cool. So we got nice movement with random Perlin noise. We're clamping our movement so we can't just go insanely fast anymore, which means also, oh, that's a problem. Oh, we're clamping the bullets too. You know, I pretty much only want to clamp the UFO, don't I? So, I would need to, okay, so we are clamping everything. Let's only clamp the UFO. I'm gonna leave that to next time though, because it is 8:23 and I need to go get ready for work. So I'm gonna go ahead. I'm gonna cut off the YouTube video here, and then get all this like sent up to GitHub, and then we'll close the stream down. So if you're watching on YouTube, thank you so much, and I'll see you in the next video.